Okay, so today, we've heard about the macro scale, so I'm going to zoom more into the micro scale now and really talk about, what happens when you give one person 1 hour, and just how far can you get when you build in such a rapid frame of reference. But to begin with, I just want to get a feel for, across the audience, what's everyone's main tool of use? And even if you haven't used any of these tools, what would be the main one that you would maybe go to as the first one that you would test? And I want to go through each of these and then raise your hand, if this is the main tool you use. So first, Claude Code. Okay, not as many as I thought, actually. And then GitHub Copilot. No, that looks definitely like one of the most dominant. And then Codex. Nice. And then anyone else who has another preference, so maybe something like Windsurf or Cursor or a different tool. Okay. It looks like there's a lot of Copilot users and Codex users as well. Interesting. And then I'm interested in how people are using these tools mainly, because a lot of us use it to maybe develop greenfield solutions, or we're already working on quite big code bases, and we might want to add features using these tools. So to begin with, who's mainly using it to add to an already existing brownfield code base? Could you raise your hand if that's your main use case? Expect that to be probably the most dominant. Okay. And then how about if you're using it to build greenfield applications, so from scratch? Okay. How about to assist in the code review process? You see that as the most useful use of these tools. Okay, there's a few there. And how about the final one? So probably the masochists amongst us. So using it for the autocomplete feature. Okay, interesting. Okay, so it does seem to be so it's mainly brownfield and developing for greenfield as well. So that's interesting. So today I want to talk about something that at its heart is quite simple. So what happens when you give one person 1 hour, an agentic coding tool, and then they're tasked with developing something real? And so I want to step through that by going through what do I mean by this 1 hour experiment? And then also, so how did this hour play out in reality? So how did I go from some idea to some working reality in that fixed space of time? And then at the end of that experience, what were my lessons from that, in terms of best practices and how to get the most out of these tools? And then also to end, so what does that really mean for us as practitioners and developers going forward? How should we best use these tools? Okay, so in terms of the hour experiment, so how do I define that? So you have an hour, and this is based on a real hackathon experience that I went through. And then you have an unseen list of 6 tasks that you've not seen before, so you've not had time to prep or anything. And then you choose a coding tool, so you choose an agentic coding tool of your choice. In this case, I chose Claude Code because I'd mainly been using Codex, I'd used Copilot, and I wanted to just compare and contrast different tools. And then also, the aim is to get to the end and build a prototype or a proof of concept. And so the task that I actually selected was a screenshot finder. And the idea behind this is that you have a bank of images taken from your laptop, and then you want to be able to search against that bank of images, but you don't only want to search for the text contained within the images, you want to also search against the description of the images. So you might be interested in the text contained, but also a more broader description, visual description. And a good way to think about this is if you go into your Android and you go into Google Photos, that is actually using quite a similar mechanism. There's different models at play there, but actually there are models that are used there that use something quite similar. So you can think about it almost like in Google Photos, I can search for something quite concrete, but I can search for something quite abstract as well. So I might say something like bright sunny day, and then it comes back with all the photos there. So I'm not looking really for objects. I'm more like describing something more widely. So that's the idea behind this tool. And then in reality, so how did the hour actually play out? So here I'm going to zoom in more onto the framing and design. So that's the part that I see as absolutely crucial. And if you don't take anything from this, then it's mainly just how important planning and design really is, when you're actually developing quickly, and especially important when you're developing on such a short space of time. And the framing and design really, you need to spend a significant portion of your time there. And that's really where you're exercising your expertise in thinking about, so how do I actually develop a solution like this? And that's where really I was using my experience as an AI consultant to think about, well, what methods do I really need to develop a solution like this? But also in the planning stage, I need to be really careful about how I define the problem. So I need to set a constraint and a core goal. But then also I need to think a little bit about architecture. So instantly when I see a problem like this, I'm thinking, do I use a vector database? Do I need to use open source models, or do I want to use closed source models? So there's a lot of important decisions that I'm having to make. So I'm still having to exercise my expertise that I've developed over time to then constrain the model so that I can develop something useful that I can then take on forward. I might want to take it from a prototype to then something that I might use in production. So it's really key to build incrementally. So when I was actually building this tool, I started out with something that I could run in the terminal. So I could open up my terminal and make a search in natural language against my screenshots. And then once I was happy with that and I tested it, I could then go on to think about, okay, I want to demo this. So I want to put a front end in front of it so that I can demo the application. So that's the important part, to start incrementally and then steadily build on top, once you have your foundations in place. This is just to show, and this is really where your expertise comes in, as an AI consultant. So I'm looking at this through more of an AI lens, because here we're using an agentic tool to develop an AI application. And from my experience, I might see this problem and I'm already thinking about the particular techniques that I might use to solve it. So the problem's describing, okay, I need to search against the text in the images. So that's instantly saying to me, okay, I might want to use an OCR model. And then also, I need to learn about the visual description of the images. So that's where I might use something like an image understanding model. And that example there in the bottom, shows an example with Abbey Road. But that's how these models are typically trained. So you have an image, you have a textual description, and the models are trained on a whole bank of these images. And then when a new image comes along, you then are left with a visual description. And then at the top as well is a RAG architecture. So a lot of people might have heard of RAG architectures, but that's really a way of querying a system, and I want to retrieve back specific information that I have stored away in a vector database. This is not a lecture on AI techniques. I could spend hours going into these models because I'm fascinated by it, and that's where I spend a lot of my time. But really, this is just to show that your experience matters. Your experience matters in constraining the problems. We can all vibe code, but typically I might be left with something that I just can't use. Maybe there's a time and place for that, in a client meeting where I quickly want to demonstrate where we might be able to go with something quickly. But I think when you want to build a solid foundation, it's key to actually constrain the problem as much as possible. And now this is zooming more into Claude Code directly. So within Claude, you can use a planning mode, and a lot of these tools have an equivalent. And essentially, this is where you iterate on your plan. And I like to finish really with a finishing plan that has lots of steps for me to get to the final solution. And I like to break it down into a multi-step plan. And this phase is really important, that you constantly iterate on this plan and you just don't leave any gaps. So you don't want to leave any freedom for the system to improvise. You want to constrain it as much as possible. And what's quite nice with Claude Code is that it integrates quite nicely with GitHub. And so that means that when I've arrived at my plan, and then I want to persist that plan for the future, because I might want to leave my session, return back, and then start with the development stage midway through my plan. I want to persist that so I can return to it. And within Claude Code, it allows you to do that quite nicely. So this is showing within my terminal window, I'd reached the end and come to terms with my plan. I was happy with my plan. And then what I can do with the integration with GitHub is describe in natural language, I want to save that plan. And then my plan is then saved as a GitHub issue. And I quite like this because we can save it as Markdown, but it's quite easy when you're developing quickly to not commit, quickly make changes to your plan without realizing it, but then you want to actually return back to your original plan. And I just think this is quite powerful because once that sits there within GitHub, you can refer back to it in natural language. So you can say, let's resume from step 4 and then continue with the development process. So it's a really powerful way really to work with these tools, especially when you're developing quite quickly. And then I just want to show where we got to in the hour. So this just shows the application and making a number of searches. So here I'm making a search, don't ask why there's a UFC search. That was one of the screenshots, that was within the bank. It was a general open source data set. And then what you can see is it shows confidence scores. So it shows confidence scores in the query, but it's searching against the OCR text and the visual descriptions as well. So you can see here I'm doing a search for mathematics, and there's a Mathematics Society page that ranks at the top, but it's using the text and the visual description from these pages to rank these images. So this is all using open source models. I'm not using any cloud integrations here. I'm not using a vector database. I wanted to keep it as simple as possible so that I could then move on from this and develop something further if I wanted. So it is quite impressive how fast you can go in that amount of time. But I think the key message really is that it's just so important to constrain these tools, if you want to get the most out of them. So really in terms of the lessons that came from this, one of the main ones for me really was that design matters more, not less. And I think really that's a key learning, that there has to be good architectural thinking that comes behind the development of the solution, because otherwise you end up developing the wrong thing, but just faster, which isn't really useful for anyone. So yeah, they definitely compress the execution time, but they don't really replace design, and architectural thinking. That's a key part. And then as well, clarity matters. So getting the specification right is absolutely critical. So you need to spend a considerable amount of time into planning. So you want to remove as much ambiguity and then iterate on that plan, as much as possible. You don't want to leave any loose ends. And I like to think that ambiguity really builds technical debt when you're developing with AI, because you have so many areas of the code base that you don't quite understand. It's not constrained at all. And vagueness just compounds very quickly. So I think you just have to be on top of that by putting together a specification that's as concrete as possible, really. And then the final one, I think this one is probably most interesting to me, really, in how I see things have moved, especially looking at it through an AI lens, so me as an AI consultant, because I think back to the time when we tackle a number of problems, and especially in AI, there was a lot of uncertainty, and there still is a lot of uncertainty when you're working on a number of different problems. But I think now we can learn just very quickly. We can learn, okay, we don't want to continue with that path anymore because it doesn't appear like that will give us much, and we can quickly pivot and change our approach. So the learning cycle is very quick, and it's got even quicker now. And I find that most interesting, because you can think about the days where you might have a 2-week spike within the sprint. Now you can reduce that to hours or days. So things are shrinking hugely, and I think that's really interesting, because you can really then start to push your ideas to the limit, in terms of what is possible, and really test that quickly and iterate on things. So what does that really mean for us? To summarize, so it's showing that you can move to a prototype quite quickly, and this is showing that that happened within an hour. But it's still really important to constrain the problem as much as possible as well, and treat the design really as an important development asset. So whether you persist that, you need to treat that as like a really key asset in your development process, and spend a good amount of time there. So I think really it's showing that these tools, they're really changing how we design and how we develop products. And I think that's one of the main shifts that I'm really seeing with these agentic coding tools. So that's everything I wanted to cover. So thank you very much for listening. Thanks.